Draw a graph, a rough sketch. Does it have to be exact? No, it doesn't. X goes from 2 to 14. So let's just say that's 2, and this is 14. What, 5 and 10? And then it goes from, what, 12 to 30? Let's just say that's 12, and that's 30. Great, I have a little squiggly line here, a little squiggly line right there. Let's plot these points. 2, 12, 5, 28, 10, 34, and 14, 30. So something like that, right? About. So it says on the intervals 2 to 5, 5 to 10, and 10 to 14, and you're using, what are you using? Subinterval, what type? Right. That's the key word right there, right. So the first interval is 5 to 10, so this is the first rectangle you draw, and it's not really a rectangle, that's a terribly not level, like that, and then 5 to 10 is going to be up to here, all the way over, and then 10 to 14 is going to be right there. So you find the areas of each of these. It told you that at 5, what was it? 28. So that's 28 right there. And what's this one? 34. And this one is 30. So this is going to be, so for this one, from 5 to 2, it's going to be 3 times what? 28. And the next one's going to be 5 times what? 34. And the next one's going to be 4 times 30. And you got 4 because it's 14 minus 10, you got 5 because it's 10 minus 5, and you got 3 because it's 5 minus 2. So you're just adding all of that together. If you add that all together, what do you get? Equals, so yeah, 374. And is that one of the answers? Yeah. There it is. There's the right hand. You know, so what would left hand be if you did the left hand, just for example? My guess is it's there. If you do the left hand, it would be that height, and this height right there. You see that right there? So this is the right, sorry. So what would the left be? What would the left be? It'd be 3 times 12 plus 5 times 28 plus what? 4 times 34. It might be about the same because one of them went above. Not necessarily so. Oh, yeah, you're right. They do cancel, so they come out to be the same. So it's going to be a lot less. You're right. So it's going to be 36 plus 140 plus 136. So it's 176 plus 136. So that's going to be 312. Is that answer there? That answer's there. So they make. I wonder how they determine the other ones too. Maybe if someone used midpoint rule or something like that and estimated, or they just looked at it from a Anyway, insects destroy a crop at this. So let's just call it R of t. Literally, you could do this on your test. R of t. Also, this is multiple choice. So do they care about your work? No. If this was a free response question, which it could, then it says to the nearest ton, how many tons did the insects destroy from 7 to 14 days? How do you solve this? What do you do? What do you calculate? You calculate the integral from of due to say R of t dt. If this was a free response question, you could label that R of t and just write R of t. That's fine. That way you don't have to write it again. And how do you do this? You better use your calculator on this. How many of you used your calculator on this one? Everybody else, take your calculator out and do this right now with your calculator. Yeah, very good. 124.994. 124.994. So you round to the nearest ton, and it's A. Yay! So what do you do first? You enter in the function. What is the function? Parentheses what? What was it? Someone read it to me. 100. Yep. 0.1x, like that, right? Divided by what? 2 minus what? Like that. There's your function. So you quit out, and if you have the updated operating system, it's going to look like this. And you're going from 7 to what? 14. And then if you do this, you get y1, and you have to dx. You get that. If you do it out on your other calculator, you have to put the function in, so type it in properly. It'll look a little different because it'll probably flattened out. But if you plug in y1, you're then going to have function int. It'll be fn int, comma y1, comma x, comma 7, comma 14. And you should end up with pretty much the same thing. The decimals might be a little different because is your calculator numerically doing this integral? No, your calculator's estimating it. It's literally just doing a whole bunch of rectangles and adding them up. Literally. It's not doing algebra. It's not doing calculus. It's doing an estimate. And the estimate in this case is good enough because it's just going until it gets to like 10 decimal places. On this one, there's only one answer. If you had, this one asks for the nearest ton. But if this was a free response question and you need to give the 3 decimal places, there would only be one correct answer. What would it be? 124.994. But what I'm saying is sometimes, let's just change this a little bit. Let's just say the answer was, we did it, it was 129.9956. Oh, let's just make it a little less cascadey. Let's say it was like that. It kept on going. There would be 2 potential answers: 129.985 and 129.98. They would accept either one. So this would be truncating right here. This would be rounding. Either one is acceptable because they're really commonly taught, both of them. And it's not super important that they dictate which one because it doesn't really change the calculus at all. At all. Mean value theorem, do you remember pictures that look like this? You definitely covered this. Here's a function from here to here. You connect the two. That right there, the slope of this line, is the average rate of change from A to B. Somewhere, at least once between A and B, if this is x equals A and this is x equals B, at least once between A and B, there's an x value such that the derivative at that value is equal to the rate of change from A to B. How many times does it happen here? Looks like it happens twice. It happens here and it happens here. This one is saying you have a function, x plus ln x. What is the value of c for which the instantaneous rate of change of f at c, x equals c, is the same as the average rate of change from 1 to 4? So what do you need to find first on this? The what? The average rate of change from 1 to 4, which is just another way of saying what? Find the, not derivative, find the slope from 1 to 4. So how do you find the slope from 1 to 4 of this function? F of, no, minus f of, all over. Do that for me right now. Find me what the slope is right now on your calculator. Do that right now for me. Hit enter, and then what do you divide it by? Do not round this. If you round this, you're going to get an answer that's incorrect. What do you do at this point? Store it as what? Store it literally as alpha A. There you go. You stored it as A. So now when you go back to this, now you're trying to find out where is the value between 1 and 4 such that the derivative, the instantaneous rate of change, is this. So you're trying to find when f prime is, when does f prime of x equal, we'll call it A, right? When it's equal to A. What is f prime in this case? Yeah, so you want 1 plus 1 over x is equal to A. So 1 over x is equal to A minus. So what does x equal? 1 over. So you literally go back to your calculator, and what do? 1 divided by? A minus 1 over 1. We subtracted 1, and we just flip it, so it's 1 over A minus 1. Yeah. So 1 over, what? Literally, A minus 1. Press enter. There it is. Does that match one of the answers? It does. It really does. So the key is don't round, don't round, don't round. There it is, right there. So it's going to be right there. Luckily, the other ones are pretty far off, so if you got really close to 2.164, you'd be relatively certain, like even if you rounded before. But be very careful. Do not round until the end. Know how to store things on your calculator. Take the what? Yeah, so f prime is going to be equal to, sorry, f prime of x is equal to what? What h prime of minus 3, right, times what? Plus times what? What rule do you have to use if there's a chain rule? Times what? You're not. This is h of x squared minus 3. It's not h times x squared minus 3. Oh, so what do you multiply by? 2x, right? So what's f prime of 2 going to be equal to? H prime of what? 4 minus 3 times what? 4. So you end up with 4 times h prime of 1. There it is. Okay, kids, so what u substitution do you make? U is equal to x squared, so du is equal to, kids, dx, so dx is equal to 2x, so it's the integral of x e to the u times du over, and you're left with 1/2 the integral of e to the u du, which is 1/2 e to the u plus c, but what does u equal? E to the x squared plus c. 1/2 e, where is it? First one, 1/2 e to the squared, there it is. So to find the second derivative, what do you need to find first? So f prime of x is going to be equal to 2 times ln x times 1 over x. Is that right? Yeah, there you go. So then what do you have to use to find the second derivative? Quotient rule? You could use the quotient rule. What else could you do instead? You could. You don't have to. But yeah, you could just change it to x to negative 1 if you want. So you have 2 times x to the negative 1 times ln x. So yes, you could use the quotient rule, but you could also use the product rule. So this can be 2 times the derivative of the first times the second plus the first times what? Like that? So then what do you end up with? 2 times negative ln x over x squared. Is that correct? Plus 1 over what? X squared. Nice. Okay, so then what is it asking you to do? So f double prime of root e is going to be 2 times negative ln of root e over e plus 1 over what? E. Square root of e is e to what power? E to the 1/2 over e. It's just this plus 1, right? Like that. Same denominator side of the fraction. What do you do with that half? Bring it to the front. 2 times negative 1/2 ln e plus 1 over e. What is ln e? So this is going to be negative 1 plus 1 over e. Oh, so negative 1. Negative what? Sorry, negative 1/2 times 2. Yep. So what do you end up with? 2 times 1 over 2e. So it's 1 over e. Is that one of the answers? You don't have to use it. You can if you want. Exam. What do you notice, though? Okay, what's the similarity between these two integrals? The prime is the only thing that changes, right? It's f prime g and g prime f. What does that remind you of? It reminds you of the product rule. So here's a question for you. If you have f of x times g of x, and you take the derivative using the product rule, what do you get? F prime of x, g of x, plus what? G prime of x, or yeah, keep it in order, yeah, f of x times g prime, sure. Now here's the thing. Here's a move you haven't done yet, but this is something you would do in BC, and if you take more calculus, which I think most of you will see this. If I just took the derivative, could I integrate both sides if I wanted to? Yeah, well, if you do to one side, you do the other. I'm going to integrate both sides from 0 to 1, okay? I'm just going to integrate it. What's on this side? What's the integral of a derivative? Itself. So you're doing f of x, g of x from 0 to 1. And on the other side, what are you going to get? The integral of, from 0 to 1 of f prime of x. Can you easily do this derivative, this integral? No, because you have any idea what the functions are? Ah, but you know one of them, exactly. So I'm just writing out what the integral is. Have I actually done the integration? I have not done the integration, but is this a valid thing to do? It seems kind of random. It won't be as random when you learn about integration by parts, but here's the thing. Do you know what one of those equals? You know what this one equals right here, right? So what is that one? That's just 5, right? This is the one you want, right? You don't know that one. So what about over here? You're evaluating that function from 0 to 1. So what is that going to mean? It means f of 1 times g of 1 minus what? F of 0 times g of 0 equals 5 plus question mark. Now you use the chart. F of 1 and g of 1, what's that? 4 and 3. And f of 0 and g of 0, what's that? 2 and negative 4. Like this. So what do you end up with? 12 minus 8 plus equals 5 plus this. So question mark is equal to 15. Thank you. Is that one of the answers? Yeah, it is one of the answers. This right here is tightly related to integration by parts, which is not something you need to know how to do. And technically, we didn't use it, but you would not be expected to think of this. This would not be an A/B question, although it's kind of a neat thing to be able to do. The one thing that's nice is that I had done this one before. The first thing that struck me was, oh, okay, you have f prime g and g prime f. Automatically, you should think of product, or you should automatically think of that. So we need to get back to a simple question, which was this. I asked you this before. This is something we did a couple days ago, where I asked you if I gave you y equals x squared, and I said rotate it around the, let's say we rotated it around the y-axis. How did you do that? Remember doing this? We drew the reflection, and you drew one side of it over here, you drew the other side of it over there. And then what shapes did we draw? What did we stack up? We stacked up a whole lot of what? Well, washers. We call them washers. Washers. Okay. Here are the washers, right? See these washers? See that washer? We stack them all up. This is y equals x squared from x equals 0 to x equals 1. Find me that volume right now. Do that right now and show me that you can remember how to do it. Do that right now by hand. Y. Okay, so what are we looking at here? You have the integral of something dy. What goes on the outside of this integral? Pi. And you're integrating from what to what? 0 to 1, and it's literally big R squared minus little r squared. So you need to write big R and little r in terms of what? In terms of y. Do that now if you haven't done it. You know it's 1. It doesn't change. Here's the big radius right here. It goes from here all the way out. There's your big R. And it's always 1. So what do you have? Pi from 0 to 1 of 1 squared minus, and the little r goes from here to there, right? So that point right there, that's, you go over, you want in terms of x or y? Y. So if this is y, what's the x value? Root y. Exactly. So what's that little r going to be? Root y. So it's going to be root y squared dy. So you're integrating pi times 0 to 1 of 1 minus y dy. So if you finish this, what do you end up with? Pi times y minus y squared like this from 0 to 1. And what do you end up with? Pi over 2. You end up with pi over 2. So here's the deal. The volume when you rotate that is pi over 2. So here's the thing. We took a little slice and we rotated it around and we got a washer. There is another shape you can generate by rotating a different piece. Let's see what it looks like. I'm going to draw the same exact thing. Instead, what I'm going to do, so we have y equals x squared, so I'll draw that. Here it is, y equals x squared. And we're going to go from, again, 0 to 1. So let's go from 0 to 1. Let's say x equals 1. So what do you do first? You're going to draw this, you go back like that, and you draw the other side. Wonderful. So what did we do before? We draw a little slice that was parallel to the x-axis, and then we rotated it, and you got a lot of wash parallel to the x-axis, a little slice like this, and we got a lot of washers. Well, I'm going to draw something a little different. I'm going to draw this piece right here. I'm going to draw a little rectangle, because how many times have we drawn rectangles like that? A lot. I'm going to rotate that rectangle instead. I'm generating the same shape. I'm rotating the same piece, but I'm rotating a subset. Instead of a horizontal line, little segment, I'm rotating a vertical segment. It's going to be a cylinder. It's just going to be a cylinder. It's going to be a little tube. So what does this look like? Looks like this. Yes, and it goes behind like that too. Yes. So you can think of that as a paper towel tube. I've exaggerated the thickness. Theoretically, the thickness is really small, right? So how many of these cylinders are we adding up? An infinite number of them. We have concentric cylinders. So how do we figure out, kids, William, how do we figure out the volume of this cylinder? Well, what you do is you cut it right here along one of those pieces right there and unfold it. If you unrolled it, you would end up with something that looks like this. It would be really thin because it's the same thickness as it was before. But do you see how this turns into this? If I undo it, if I cut a paper towel tube and unroll it, you end up with a rectangle. You kind of see that there? Now, this thickness right here, it's really hard for me to do, but do you see that thickness I'm filling in right there? The thickness right there? It's the width of this thing. Is that a dx or a dy? Is that going to be infinitesimally small part of the x-axis or infinitesimally small part of the y-axis? Dx, yes. So what do we have here? We know that this thickness is dx. If this point right here is x comma f of x, how tall is this tube if that's x comma f of x? How tall is it? It is f of x, correct. So this width from here to here, sorry, this height, I mean. So the height of this thing is f of x. Do you agree with that? Now, what does the length of this rectangular piece, what does it correlate to? It correlates to the circumference, right? How do you find the circumference of a circle? Circumference is 2 pi r. But in this case, what is the radius? No, it's just, no. X towards the height. It's just x. The horizontal distance from here to here, this is the radius, do you agree? The radius in this case is just what? X. So in this case, what is that? 2 pi times x. So how do you find the volume of this three-dimensional sheet? Volume is 2 pi x times what? Time f of x times dx. How many of these are we adding together? An infinite number of them. What's the smallest x value you're starting with? 0. And what's the biggest x value you're going to? 1. So what are you integrating? You're integrating 2 pi from 0 to 1 of x f of x dx. Now, we haven't even talked about the specific. Have we specified what function we're dealing with yet? No. What is f of x in this case? So now we plug it in. So this right here is the general setup for what you're going to be using when you do integration by rotational solids with cylinders. These are cylinders. So instead of f of x, what do we write? So it's, we do from 0 to 1 of x times, yeah, this shifted a little bit, hold on, x times x squared times dx. Is this something that we should be able to integrate? Yeah, it's x cubed dx. What's that going to be? 2 pi times 1 what? 4th x to the, from 0 to 1. Plug in 0, what do you get? So what do you end up with? 2 pi times 1 over 4, which is that the same thing we got before? It should be. Now here's the question. Here's the key question. You don't have to totally understand this method yet, but do you understand it's a different method than we used before? Sure. We ended up with the same answer. What's the point? Or what's one of the points to having two methods that do essentially the same thing on this one? Why would you want to know another way? Maybe to check it, or maybe one method. You kind of said what I'm getting at both of you at the same time, which is good. What did you say? One method might be really, really, really hard. There are three possibilities, and whoever's tapping the bottom of the table, please stop. One of the methods, cylindrical shells or washers, one of them might be easier than the other, or they might be equal difficulty level. But the point is, you might run into a wall. You might be setting up a washer problem and realize it's really, really, really hard to integrate. So you change it over, and all of a sudden when you did it with cylinders, it makes it much easier. So for example, let me give you one. So let's say we like parabolas, right? Say I gave you a parabola like, say I give you this parabola, let's go here. Like this. Say I give you that parabola right there, and I capped it off with the axis. So I'm just looking at, let's say, right here. I'm just looking at this. You see that? Let's say I rotated that around the y-axis. What would it look like? Well, you'd have this, right? Correct? And if I asked you to draw, if I asked you to do this with washers, you could draw the shape, right? You could draw a horizontal line right here, right? Another one right here, and then do this. What's the problem, or what makes this kind of hard? Big R and little r are attached to the same function, so you have to isolate. In this case, is this with respect to x or y? This would be with respect to y, so you need to isolate this function. This function would be something like, y equals x times x plus 2, right? So I don't know, y is equal to x squared plus 2x. You would need to get the horizontal distance in terms of y, meaning you'd have to isolate x. Is isolating x here easy? No. You'd have to use what? It'd be kind of not cool. You have to use quadratic formula. It's not going to be really fun. But how could I change this to make it much easier? Cylinders, exactly. So if I draw the same exact shape, so I have a parabola here and a parabola here, and let's just say that it is y equals x squared plus 2x like this. Let's just say that's the case. It's nice because that makes this -2 and this equals 0 like that. What are the cylinders going to look like? Well, here's one of them. The top and bottom function. What's the top function? What's the upper function? The x-axis, y equals 0. What's the lower function? X squared plus 2x. So what do you have here? You have 2 pi. What are we integrating from and to?
Why is it plus 2x?
Because it has to. I wanted it to cross at -2. It just is. Okay. From 0 to 2. Let's go from 0 to 2. Well, actually, let's go from -2 to 0 on this one because this function, the function itself is right here. This is the reflection right here.
Yeah,
No, but this function is not here, is what I'm saying. It's not there. Yes, go ahead. No, kids, plug in -2 into this. What do you get? 0. That's why this is -2, 0 right here, okay? The function here, this is the function right here. There it is. So you're going from -2 to 0 of x f of x dx. X f of x dx. In this case, what is f of... Well, in this case, f of x represents the height. What is the height of this function? 2 pi from -2 to 0. What's the height of this cylinder? Be very careful. It's going to be what? Where's the height? The height is from here to here. How do you find the distance from here to here? No, it's not. F of x is negative. The height needs to be positive. How do you find the distance from? Yeah, that's cheating. But how do you find the distance between two numbers where one is bigger than the other? Subtraction, right? What's the bigger number? 0. Negative's not a number. 0 minus what? In this case. So it's not really f of x, it's the height of the cylinder. On our first example, the function itself was going from f of x to what? So f of x minus 0 was equal to f of x. So this was a little sloppy. I guess I should have said what instead? I should have said height instead of f of x. So let's just go down here. All we need to do is say it's going to be 0 minus what? X squared. Yeah, 0 minus f of x in this case. Is that something you can integrate? Yeah, that's just a polynomial. You can integrate that. But here's the example. In this case right here, was it easy to use washers? No, it was really nasty. But with cylinders, a lot easier? Yeah. And vice versa, it can be true the other way. Sometimes washers are a lot easier than cylinders. Sometimes you have to break up integrals. Sometimes you have to break up rotational solids into 2 integrals. If you ever find yourself breaking an integral up into 2, ask yourself, would it be easier if I did the other method?